Let's talk about GPS. How does it work? And we will see there will be a system of equations, a nonlinear system of equations. So we will see that a practical question present in our everyday life has to do with a system of nonlinear equations, and this will be very, very interesting. Let's discuss the basic idea of GPS, not every single detail, but the basic idea. And the basic idea is that here we have the Earth, and our position on the Earth is somewhere, and then there are satellites in the space sending a signal, and we will find out what is the distance to this satellite. And if we know the distance to the satellite is this, then we know we are somewhere on that circle. If we have a second satellite and we know the distance to that satellite, so we know we are somewhere on that circle, and then there are two intersection points, and one of them is our position, the other one is outside in space. What we see here is a 2D visualization. The reality is 3D, and that means we don't need only two satellites, we need three satellites. And knowing the distance to one satellite, we know we are somewhere on such a square. Having a second satellite, we know we are somewhere on this sphere. And then the intersection of two spheres is a circle. So we need a third satellite, and this satellite will intersect this circle at 2 points. One of them is our position and the other one is somewhere outside in space, and this is not our position. So this is the idea. How do we get the distance to the satellite? The point is that this satellite sends a signal, and it takes time until we can receive that signal. And this time lag is measured. The time which is needed to travel from the satellite to our position, this time lag tells us the distance to this satellite. The speed of the signal is the speed of light, 300,000 kilometers a second, but we can stop the exact time when we receive that signal. Then we also need the exact position of the satellite, and then we know we are somewhere on that sphere. And our position is the unknown position x, y, z. We have three positions from the three satellites, x1, y1, z1, and 2 and 3. And then we know this is the equation for the distance, x minus x1 squared plus y minus y1 squared plus z minus z1 squared is equal to the distance d1 squared. So this is the equation for sphere number 1. This is the equation for sphere number 2. And this is the equation for sphere number 3. And what we need is the x, y, z satisfying all three equations. And there will be two solutions. One of them is our position and the other one is somewhere outside in space. So this is the story. We can also visualize in 3D. This is a 2D visualization. This is 3D visualization. Here we have 4 satellites in reality. The 4th satellite is needed because of some reason, but we will focus not on the details, but we will focus on the principle of GPS. And what can you see? There is one intersection point, and this is our position. Okay, in the case of this set of equations, normally we need numerics to find the solution. It's a nonlinear system of equations, and normally we need numerics because there is no algorithm like Gaussian elimination which works also for nonlinear systems. In this specific example, GPS, there is an alternative to numerics. Unfortunately, it's not my intention, it was not my intention to show you an example where we do not need numerics. I tried to find an example from an idea which everybody of us can easily understand, and I don't have to explain half an hour, but 5 minutes are enough. And then we will get a system of equations. But when presenting that and being a mathematician, in this case, we don't need to use numerics. Unfortunately, I'm a mathematician, I have to talk about, but this is not the core information of that video. The core information was what I said until here. How can we find the solution of that system? We can expand these three binomial terms, and then we can manipulate the equations in a way similar or identical to Gaussian elimination. We can eliminate the squares, and then we have a linear system. And after having a linear system, we can find the solution. In this case, it's an underdetermined linear system. And then we have a solution with which is a straight line. And I want to show you the details. Let's do that. Okay, so expanding the first equation, we get this. We get this one. Okay, expanding the second equation, we get this one, and expanding the third equation, we get this one. I only expanded that part, and for that part, something very similar to that will show up. And expanding that term, again, such a block, we have 3 blocks of that kind, more or less identical, but instead of x a y, or instead of x a z. Okay, having that, we have 3 equations, and now we can subtract. Okay, and subtracting equation 2 minus equation 1, we get the following. Equation 2 minus equation 1, these two will cancel. Equation 2 minus equation 1 is minus minus is plus, so 2 times x1 times x minus 2 times x2 times x. And then we can factor out, and we get 2 times x1 minus 2 times x2 times x. And it's very important to understand which are variables unknown and which are known variables. x1, x2, and x3, and y1, y2, y3, z1, z2, z3 are knowns. These are the numbers corresponding to the position of the satellite. These are numbers in the calculation we have to do. So this is some number, 7 or 4 or minus 2.1 or something like that. X is x. It's the unknown x coordinate of our position. So this is a known, this is the unknown. And then this equation minus that equation, we will get that it's a known. It's 7 minus 2, and this is equal to 5. And this is the distance to the satellites. It's some number. So this is also some number. Okay? And doing that for x, we can also do a corresponding, doing the same for y and z, and we will get identical, more or less identical blocks. Okay? And then what do we see here? There is some constant times x, some constant times y, some constant times z equal to some constant. If you bring that, all these on the right hand side, then there will be a linear equation. And this will also be a linear equation. The unknown is x, y, z, and all the other variables are numbers, some numbers, given numbers, not unknowns, but given numbers. And this is a linear system, an underdetermined linear system. So let's find the solution. The solution will be in a form, the straight line form, and this is a parameter. This is not some S value which might be 5.4. It's the parameter for the straight line, but these will be 3 numbers. Okay, given this linear system, underdetermined linear system, we will get a solution. This is a parameter and these are numbers. Okay, then we can take this general solution of that system and we can substitute that x with this and the y with this and the set corresponding. Okay, and what will we get? We will get this, and now we can expand that part, and so we will get some quadratic equation. Again, b1 will be some number, but s is the parameter. This will be some number, this is the parameter, this will be some number, and so on for this first part, and then we will get corresponding something for y and z, but it will be a term of the form s squared times something, s times something, and some constants, and bringing that constant to that side, we will have a quadratic term in S equal to 0, and there will be some formula. We call it the ABC formula, or we call it the midnight formula, and we can solve that equation. We get 2 solutions for S. Then we take that S, put it in here. We get 2 points. One of them is our point we are standing, and the other one is somewhere outside in space. Okay, and this is the way how we can avoid the numeric part to solve the equations, but this is a speciality of GPS, and normally having a set of 3 equations, 3 unknowns, we have to use numerics to find the solution. But let me talk about one thing which is the most astonishing, I think the most astonishing. And the most astonishing is not the mathematical part. This is not so hard. It seems to be hard if you hear it for the first time, but if you take some time to really understand, then it's easy mathematics. But the engineering part is a wonder, a miracle, one of the greatest miracles I can imagine. If I did not know that GPS works, I would never guess that it can work, because The most critical thing in my view is stopping the time when we receive the signal. And the signal travels with light speed. Light speed is 300,000 kilometers a second. If you press your stopwatch, this was the point of time when we received the signal, and the accuracy is 1/10 of a second, then the accuracy of finding our position is 30,000 kilometers. It would be a disaster. We need 1 divided by 10 to the power of 9 seconds. 1 divided 1 billion. Don't confuse if you are German. A billion, an English billion is a German Milliarde. So don't be confused. I definitely wanted to write in that way. But we need this accuracy, and if we have this accuracy taking the time when we receive the signal, then our position has an accuracy of 30 centimeters. And that's what we want to have. Maybe 1 meter is enough, okay, but 10 or 20 meters are not enough. If you drive your car and you are told, please drive to the right now, you don't want that it's 30 meters before or after when you really have to turn right. So we need a very, very high accuracy for the time, and I think this is more or less a wonder. You need this accuracy in the device holding in your hand, not the satellites. If the satellite costs more, 10,000 euro more than it normally would, that's no problem. But you need this accuracy in your hand. Everything to determine your position will be on your device. The logic is not on the satellite. The satellite only sends his position and the exact point of time when the signal leaves the satellite. That's all the satellite does. And everything else will happen in the device in your hand. And this device needs this high accuracy. And this is really, really kind of a wonder, I think. But in the end, let me emphasize this is the part for motivating our numeric section about solving systems, and everything added after was to talk a little more about some details of GPS, which are very specific details concerning GPS. The main thing I wanted to say was here.